Hello everyone, today we're going to take a quick dive into the topic of differentiation. This is the last topic in our final term syllabus. This is a rundown for those who are absent and those who do not know what the fuck is going on. So, what is this dy by dx bullshit? What it's doing, it's basically just taking in the slope of the tangent. Okay, but since we don't have that much time, I don't really think I should explain you how all this shit works and tell you a few life hacks. Firstly, if it mentions anything about gradient gradient of the tangent, if it mentions anything about this, then you know it's immediately just dy by dx. Okay? Good. Now that we know this, we should start. First, let's give a question. Find, let's say we have a question right here. Let's say find dy by dx of this function 2x squared. Okay, the formula for this, remember this, is ax to the power n is anx or n minus 1. Okay, since if we know that, that means dy by dx is some dx of this. So, okay, hold on. Before you begin, a little important thing you want to keep in mind is that when you write down the question, say dy by dx, and then you give some equal sign, something like that, and then write again 2x squared, something like this. This is actually wrong. Please do not do this. You'll get your marks deducted. Because when you're writing down the notation dy by dx, that means you're already differentiating it. Meaning you have to write it with the differentiated part. This is going to be this. This is correct. Okay? This, you see, this is correct. But not this. This is wrong. This is wrong. This is correct. So, now that we know that, let's start writing this down. So dy by dx of this part, let's erase this, we don't really need this anymore. Dy by dx is, again, this 2, this constant would stay as it is. The power would move to the front, multiplying with that number constant. And it will remove itself once. So we get 4x, and that's the answer to this problem. Okay, let's do a much more harder one. Let's say we want to find the dy by dx of, say, something like root x. Wait, this is the wrong thickness. Say something like root x, or actually no, I think it's a little too hard. I think we should do something much more simpler, like 3 by x plus 4 by x squared. In here, we have to bring this to what's called a specific format, where if it's in this fraction, you bring it to this indice format, and I'm hoping you know what this is, or you're basically cooked. You bring it down to this format right here. Once you bring it down to this exact format, what do? You do the exact same thing you did before. You write dy by dx, okay, and then you write down this entire thing immediately. You don't want to rewrite this whole thing again. You just want to directly write down what will happen when it's being dy by dx. It's 1 minus 1 plus 4 multiplied by minus 2 x to the power minus 2 minus 1. With basic knowledge, I'm hoping you know what this is going. Yeah, it's 8x minus 3. And since our teacher wants it in the root format, or you can say the more proper format rather than this, we have to write it as, it's not necessary, but since our teacher wants it, this is the answer. So this, let's box it off, this is the answer. Okay, so another one. Let's do something much harder, okay? Let's do something a little more tricky this time. Let's say I want you to find the dy by dx of something like root x by 3 cubic root of x plus 5. A little hint I want you to give to you guys, a little small hint, is that dy by dx of any constant, like any number where there's no x variable, will always be 0. Okay? This is a little hint. So take your time. You can pause this video I'm sending and just finish this. Okay, so let's solve. So we have dy by dx, so we write it down as bring into a format. So firstly we have root x on top, and the bottom one is just saying x to the power 1 by 3. If confused on how this works, basically if any root to the power n is being given of any variable, it is just that variable in an inverse like this. So keep this in mind if you're confused on how I got 1 by 3. Plus 5. This top part becomes x half. This bottom becomes 3x 1 by 3. Oh, what is that? That is not a 3. 1 by 3 plus 5. Now we know that in an indice rule, if the same coefficient variables are being divided, their exponents would subtract. And a nicer way you can write this down as is actually 1 by 3 rather than this. Then you can write this x power 1 by 2 minus 1 by 3 plus 5. Now this becomes 1 by 3. This part right here, when you subtract it, half minus 1/3. 1 by 2 minus 1 by 3 gives us 1 by 6. So it's x to the power 1 by 6 plus 5. So let's find the dy by dx of this, say that it is, into 1 by 6 to x to the power 1 by 6 minus 1, and the constant goes away. From here we get 1 by, see calculator if you want. So this just becomes 1 by 18x to the power 1 by 6 minus 1 minus 5 by 6 minus 5 by 6. Right, now we have this, and that plus 0, and that's the answer. It's this one. So now that we have that, let's do something a little more harder, and I'm going to pull this from my question paper we have. I'm going to write on the page for you guys to go through there. It's going to be the white book, the white maths book, Y-Add maths book. And from it, you want to go to page number, Unit 12 is the chapter for differentiation. We're going to page number 266. Okay, number 13 and 14. It's a must. You must do these. You at least do these two. So, yeah, let's solve them, I guess. So let's start with number 13. So, number 13 says, the gradient of the curve y equals to a by x squared plus b by x at a point minus 1 by 5 is 4. So, find the values of a and b. Alright, we'll find a and b. Okay, from this, we know a few things. Firstly, how many, we have two unknowns. We need minimum of two, actually not minimum, for a minimum, we need two equations. And what this question is telling us is, at this specific point, the dy by dx of this variable is 4. So the dy by dx is equals to 4. Firstly, one more thing we can do right now is, this is the x and this is the y, right? We know that. So if that's the case, let's substitute this in this equation at first. 5 is equals to a by minus 1 squared plus b by minus 1. And from here we get a minus b. That does not look like a b, that's like a 5 actually. A minus b is equals to 5. Right, now that we know that, let's do the second one. The second part of the equation, this says dy by dx is equals to 4. That means let's solve the dy by dx of this variable. So first we bring to the format ax to the power minus 2 plus bx to the power minus 1. Okay, now that we have that, let's solve. Firstly, we have dy by dx. So dy by dx is equals to, then we write it down, this whole part, which is minus 2a x to the power minus 3. I'm skipping the step where it shows the addition, because I already showed it to you. You can skip to this point in the video, I guess, or some shit. So minus b x to the power minus 1 is just minus 2. Right, so this is what we get. Bracket around it. Now, the final dy dx is 2a x to the power minus 3 minus b x to the power minus 2. Right, let's write this down a little more nicely. This is just 2a by x cubed minus b by x squared. That's all that's going on here. Now, we know that this dy by dx value is 4, right? So, that's 4. And we also know that that x is equals to minus 1. So, minus 1 cubed minus b by minus 1 squared is equals to 4. Right. Now let's do this one again. Let's see, this becomes minus minus cancelled. This becomes 2a minus b is equals to 4. And that's our second equation. Okay, we have our two equations now. It's this one and the one we did before, which is this one. Let's lasso this bad boy. Right? Yep. Now we just do basic substituting, and let's see. I'm gonna directly put this in my calculator for simultaneous, but you can do it manually. I'm just gonna show you the answer, and the answer is minus 1 and 6. Once you solve it, we get minus 1 comma 6. That's your a and b value. Now, in the same way, we solve for number 14, which states the same thing. It's the same thing, it's just Now the fraction is just half comma minus 13 by 2. So yeah, that's basically it. And another extra thing, I'm pretty sure, I don't remember if we did it in class or not, if in any way we are told to find a differentiation of, let's say, something a lot like a binomial type stuff, like 2x plus 4 to the power of 20, and you have to find differentiation of this, you can use this small formula where it is you bring this to the front, we minus 1 from here, and then we find the differentiative value of the one inside. So here, let's say we got 20, then 2x plus 4 by 19. This is being multiplied, now the differentiative value inside, which is just 2. When you differentiate 2x, this dy dx, this one also dy by dx, we get this. So what we're left with is 40 multiplied by 2x plus 4 to the power of 19. If you spend your time doing the binomial and manually doing it, the answer of this and that will be exactly the same. So yeah, I'm pretty sure we're not getting this, but just in case, here it is. So that's it for today. This is the basic differentiated formulas. Just now I'll give you the important ones. Do from hold on, from 12C, right? Firstly, from 12C, you must, of course, you already know, 13, 14. You must also do, if you can, number 15, 15, all the way up to 17. So basically, yeah, you must do everything from 13 to 15. Okay, you must do number 2 to 3, and from review problems, do 1 do 1 to 7. That's all. That's all for differentiation. You can screenshot this, you can send it, whatever, but do these are very important. These ones are the most tricky and will be hopefully the most common questions. That's for today. That's for differentiation. Now, go out there and get an A star.